Good morning, everyone. Myself, Deepak Agrawal. I'm from Research Computing Services at University of Cambridge. Thank you for coming to the workshop 2 of this NFCS project on MyAccessID. Uh, we had a very good workshop 1 where we went through why MyAccessID is one of the good solution for identity-based authorization for the HPC service providers. One of the topic that came out of workshop 1 is how do we support users who are not part of MyAccessID without breaking the federation model and making sure we are able to enforce our policies for various HPC services. So the idea of this workshop 2 is to talk about how do we extend the authentication beyond MyAccessID federation and use something called identity connectors. So we will see what identity connectors we have used and implemented in one of the services that we are running at Cambridge. So in this talk, I'm going to talk about what happens when the federation is not enough, and more importantly, how do we extend authentication in a way that is scalable, secure, and operationally manageable. So in this talk, I'll walk you through the problem that we encountered and how it manifests in real system and how we solved it using the identity connector solution. So just a quick recap of what we did in the previous workshop. So MyAccessID is a federated identity solution built on top of Edogain, which I think many of us are already familiar with. The key value that MyAccessID provides is trust. And as a service provider, we don't need to manage the user identities and passwords. And we don't want, I mean, as a service provider, we don't verify the identity ourselves. This is where MyAccessID has helped us in delegating the authentication to trusted institutional identity provider. So MyAccessID gives us persistent attributes, consistent, identifiers, and a high level of assurance. What's important here is MyAccessID helped us in making the shift of the burden of managing the user identities away from service providers. Uh, for some of us, it may not be a big deal, but for the service provider who manage thousands of users, that's a very big deal operationally. And it's quite expensive as well in terms of compliance, support, and the security. But the model of MyAccessID was not complete, and this assumes something which is very important. So just going with a quick recap again of on how we are using MyAccessID for the Air Service portal. So Air is a service which we are running as one of the site for providing the Air resources. The other site is University of Bristol. So the way in which we have implemented MyAccessID is, so there is a project management portal which is based on Voldo. So users have their projects created in Voldo, and then the users are invited through that portal. And when they receive the invitation on their email address, they accept the invitation. To accept the invitation, they need user ID and password. So MyAccessID is integrated into that portal. They choose MyAccessID, they go to the they then choose their university, and then they provide their university credentials. They authenticate using the university credentials and accept the project invitation. That's how the authentication problem is solved, and the authorization is given by Voldo, in which project they have the resources, what resources they can access. It can be compute, it can be storage, it can be secure infrastructure. Potentially, it can be anything, as a service which you want to authorize the users for. So this is how the MyAccessID has been working for the air service portals, both at Cambridge site as well as at the Bristol site. Now, coming to what was the gap where MyAccessID Federation actually failed. MyAccessID assumed that all users belong to the federated institutions, but in reality, that's not true. In our environment, we regularly onboard users coming from industry, working on a joint project, government users who are not part of EduGain, some external collaborators from outside UK, and users, sometimes the users from the universities with incomplete or inconsistent attributes in EduGain. And this makes it harder for us to direct people to, MyAccessID and do the authentication themselves. So as we can see clearly, there's a gap, and the solution that we have built is not fully federated. So what do we do with these users who can't use MyAccessID? And just to tell you, this is not the edge case. In today's time, we have projects where in a single project you'll have users from university, you'll have users from industry, you can have users from outside UK as well. So in this collaborative environment of research, there is a gap where the DRIs must support alternative authentication methods. We have been doing that by managing the local accounts ourselves as a service provider, but this creates like increasing admin overhead. There are security risks if someone's email is compromised, and it basically breaks the federation principles as well. So to address this gap, we came across something called identity connectors. And think of identity connectors as controlled extension to the federation. They are not ad hoc accounts or the bypass mechanism. They are structured, policy driven ways to authenticate users who fall outside federation. So our idea of identity connectors was that they should be able to answer who the user is. They prove control of this identity from where the user is coming and which identity provider authenticated them to give the so that they get the authorization before after the authentication. Now the important part is with identity connector they don't decide and the users don't get which projects they can access. So that's not part of the identity connectors. They don't get like which resources they can use, and they don't get the login to our system called Dawn or any of our services. So identity connectors basically solving the authentication part, not the authorization part. That is still lying with the service provider in a way that we are managing. So the separation is very critical, and it allows the service providers to have a strong authentication flexibility while keeping the authorization tightly controlled. Now let's look at how it plays out at Cambridge. So in this slide, you can see before the identity connectors how we were onboarding users for the air service. So as I said, we have a portal which is based on Voldo. That is the service management portal for the air service. So users have their projects created in Voldo. They get the project invitations through Voldo. And there's a concept of PI and the project members. So there are roles as well where to define, what the user can do. Now, this service management portal is connected with Keycloak, which is our main identity broker. And as you will know, Keycloak has this concept of different realms. So we have two realms in Keycloak. one realm manages the Waldo service management portal. The other realm manages our HPC services. So like things like open on demand, as such access, and the LDAP account federation. So as I've tried to demonstrate in this box, so realm one can use identities from MyAccessID. Realm two can also use my identities from MyAccessID. So if a user is getting invited on a project, they can potentially use MyAccessID and log in to use the services sitting in both the realms. But for the non-MyAccessID users, they require a local keycloak account and in both the realms. Now in Keycloak, users are realm specific. That means a user in realm one is not visible in realm two unless the realms are federated via an IDP, like we have done in the case of MyAccessID. So a user needs separate user accounts in both the realms if they cannot use MyAccessID. And this model, we were getting a lot of tickets because obviously the users who can't use MyAccessID, even if let's say they are coming from the university. So sometimes, some of the universities, they are part of MyAccessID Federation, but still they can't use MyAccessID because the university is not releasing the correct attributes that are required by MyAccessID. So, there is like group-based access within the universities, which allows only a particular group of particular individuals who are part of a particular group to use MyAccessID. So I mean, in summary, we were getting tickets from the university users. We knew beforehand for the external users, so we were creating their local accounts. Uh, but it was a lot of admin work for us, and considering the number of users that we are onboarding for the air service, the number has grown. I mean, the number is increasing day by day, particularly the users who are coming from the industry. So as you can see, this architecture is not complete for the user onboarding. And then we came up with, okay, just to show you how the portal looks like currently. So this is the service management portal that I was talking about. It is based on Waldo. So the option that the users see is MyAccessID. They didn't see any other option. They needed the user the local account which they can put in these two blank field to be able to log in to the portal and access the services. Now what we have done uh, to add the identity connector, so we introduced something called guest IDP. uh, Guest IDP is another realm in Keycloak, which acts as an identity provider to the other two realms. So basically, we have created an identity provider within the Keycloak to provide the identities for the other realms where the services are sitting. So what it does, the guest IDP allows users to self-register themselves using their email address. So they go to the guest IDP, they do the self-registration using an email address, and they get the verification, email. Once they verify the email and set up the password, they can log in into Waldo, they can log in into Open on Demand. But of course, the important point here is the email address which they are using for self-registration. That email address has to match with the project invitation email address, because that is where the authorization is being decided, because the PI or the service providers, whoever is inviting that person, they have to make sure they are inviting that person on an institutional organizational email address, not on the personal email address. We have some policy driven control on the guest IDP. So for example, the users who can use MyAccessID, they cannot self-register. They have to go and choose MyAccessID for the authentication. uh, the Gmail, Microsoft Outlook, Yahoo email addresses are not allowed to self-register. So as I said, the idea is to make sure whoever is doing the self-registration, they are associated with an organization. And the concept, particularly with AIR, is every user that is getting the invitation, they have to be associated with an organization. So the email match and verification is a very important criteria for this model to work in a secure way. Uh, we have thought a lot about how it can break, but I mean, whatever discussion we have had, we haven't found any way. If we do the policy control in a way, which checks the email periodically as well. So it's not like once you self-register yourself and get access to the resources, you will have access indefinitely. It's driven by project, and every project has a duration. So all the access to to the resources for that user will be taken away once the project duration is over. So this model, I think is working really well. We have just introduced this for the external users. When I say external users, the users who can't use MyAccessID from that perspective. This is we have implemented around a month back, and this is working really well. We haven't seen any of the edge cases where this is breaking as of now. But one of the point that I want to say is this is just one of the solutions. So you can add other identity connectors as well. So and a key cloak allows you to add multiple external identity providers. So we are in a process of adding NHS as an identity provider here as well, and many more, in future whenever there is a use case for that scenario. So once we added the guest IDP, this is how the portal looks. So the users who can't use MyAccessID, they'll see something like guest accounts. They'll go here, they'll do the self-registration, and once they do the self-registration, verifies their email. If the email address matches in with the email on which they have been invited, they'll be accepted, and they can get into the Vaulter portal, and that's when the authorization starts and they get access to the resources. Before that, it's just a user account sitting in Keycloak without any access. So what we have done with Guest IDP, it's like a central Keycloak identity provider that enables self-service onboarding for users who cannot authenticate using MyAccessID. It gives us a single reusable identity for external users without breaking the federation or increasing operational overhead. So before identity providers, we were having multiple identities across HPC services, manual on onboarding. After the guest IDP, we have single identity, self-service access. Uh, yes. Uh, Next. Yeah. So I think I'm coming towards the end of my talk. So in summary, MyAccessID gives a strong foundation for authentication, but it fails as a federation model to onboard all the users, and the real world systems require flexibility. So identity connectors are some ways to introduce the flexibility for onboarding users for our services without compromising security and increasing the operational overhead. There is a demo from STFC just after my
Right.
talk.
Okay.
Yep.
Yeah. Well. Okay. Let's have STFC up with their demo then.
Stop sharing.
Hi. Can you hear me well?
Yeah, we can hear.
All right. So, hi everyone. I'm Simona, a research software engineer from the Hartree Centre, and today I'm going to talk about SSH federated access in HPC clusters. It builds on what Deepak already talked about, but it's more focused on SSH access, and I'm also going to provide a demo. But before going into the demo, I just want to quickly point out what problem is this trying to solve. So imagine the following scenario, which you may be familiar with. You have 5 researchers, all from different institutions, and all of them need SSH access to a, let's say, Slurm login node. Some of them are part of the edugain, some are not. Some of their institutions can provide consistent identity attributes, and some others not so much. So the traditional way to handle that would be collect their SSH public keys, install them, manage their rotation, manage their revocation, rinse and repeat. So not only it doesn't scale, but it's also a security headache, and it needs careful planning and administration. And it's also just a tedious task. So the better way to handle this would be federated identity. However, federation was largely designed around web-based authentication flows, which SSH is not. So we need a way to bridge that federated identity coming from MyAccessID, for example, all the way to the SSH terminal session. And this is where SSH certificates come into play. So the solution I'm going to show you combines 3 things. So the MyAccessID with Keycloak, and these two deal with the federated identity layer, where Keycloak sits in the middle. Then you have Conch, which is a SSH certificate authority developed by the team at Bricks. And then you have Clifton, which is a command line tool that sits on the user's machine. And it orchestrates this entire flow. So I'm going to demo that. Just let me quickly share my screen. All right, so here I have my terminal. I already have Clifton installed, which is very easy to do. It's just running a curl command. For Clifton to work, you need to have a configuration file. This one looks like this. It's a default one, a standard one, but the most important thing is the certificate authority URL. You normally wouldn't have to write this configuration file yourself. You would get it as part of an onboarding process. So now I can just simply write Clifton off, and I want to tell Clifton that I wanted to handle the SSH config file for me. So once I do that, I'm being presented with the Keycloak login screen, where I can log in either via a Keycloak local account, a brokered IDP, or through the identity connector. So I'm going to do that now. So login via connector, and I'm choosing MyAccessID here. Here I can just search for my institution. And now I can log in with my institution credentials. I grant the access to Conch, and now I can return to my terminal, and I can see the available SSH hosts. So I can just copy the Slurm one that I'm interested in and SSH into it. So now I'm in. From here on, I can submit a job to the Slurm scheduler and do everything as usual. Yeah, so the main point is that Conch doesn't, in this flow, Conch doesn't care where the upstream identity is coming from. So be that MyAccessID and the institution, a local key cloak account, or a brokered IDP, which is it is the beauty of this. However, there's two caveats, and I think Deepak touched upon them a bit earlier. One of them is that so key cloak Conch actually requires the user. Let me show you. Keycloak will require the user to have two attributes which are not standard to Keycloak. One of them is the short name and the other is the project. The short name is, it will become the principal in the certificate that's issued by Conch. And this brings me to the next caveat, which is there needs to be on the target system that you want to get SSH access to, there needs to be a Unix username. And this usually will be the Unix username that it needs to map to. So these are the two caveats. In a real world scenario, this can be solved by, for example, using safe, which can become then the attribute source for Keycloak. And then for the second caveat, with the Unix username and the Unix user existing on the target system can be solved by using LDAP, for example. Yeah, so this is how this flow works. If you have any questions, happy to answer. And if my colleague Robin wants to showcase how you can submit a job and to the Slurm node, you can do that. Thank you for your time.
We're going to proceed now with the final talk and demo, which is about what we've been doing here at UCL. Okay, so my name's James Legg. I'll be giving you the talk. Sam Reese will give you a bit of a demo after I've done that, and we also have our contributor Brian Mayer, also from UCL, will be available in the discussions afterwards. Okay, so we've been trying to build something a little bit different. A lot of the things we've heard about are big standalone HPC systems. Our model is a tenancy in a private cloud. UCL has a new private cloud system. And the occupants of this tenancy is maybe a research group from perhaps mostly from UCL, for example, but also has some external collaborators. And wouldn't it be nice if they could share data and compute and software stacks and things and make their work, everybody's work, a lot easier? We've been hearing about identity providers, so MyAccessID, channels identities from university identity providers that we can then use, and this is what we're focusing on, is consuming those identities to authenticate people's access into those into the tenancy. So why use MyAccessID? Most of these are not really specific to our little tenancy arrangement. There are 116 UK universities and other institutions already have the IDPs. If you click on that link, if you look at the slides later, that will take you through to the current list. So it's quite likely if you're considering becoming a consumer, you're already probably an identity provider, and that may help getting local approval. When we say consumers, just a clarification on terminology there, often people mean the same thing by consumer of identities, a relying party and a service provider, because that's why if you have a service, that's why you need the identities. Okay, I did myself a nice big list of regulations that apply. I won't go into detail here, but maybe we can find out which one of those, some of these did bite, particularly when it came to our setup. If Martin wants to start a dialogue on how incomplete that list is, I'd be happy to do that. Okay. Anyway, there's sort of three kinds you might be looking out for. General things that look like rules about how you use computers. There's the general law of the land, and then you've got internal regulators who have rules and opinions, and you may need their approval. Okay. Yeah. Oh, sorry. Did I not press the sharing button? I will print that again. Present in Teams. Okay. Oh, that's fine. Okay. Right. So I'm sorry. Did people not get that because it was showing me the usual view?
I think it was
So
okay. I could see.
Yeah.
your
Okay. I'll just
slides
have.
your slides were visible before
Yeah.
you.
Yeah. That's right. Yeah. Yeah. Okay. Okay. So I've pressed it again. So we'll just move along. Sorry. That's as okay. So we're talking about regulations and sources of them. And then what's really different about our private cloud thing is that we have external users in really what's the heart of the university computing system. So that can get people a little excited. And what are the reasons? Well, they're people from outside, so they're less known about. They may not even be a category of people in the minds of the university administrations. Will they come? Will there be large numbers? Perhaps not. Not compared to the number of users of a university computer system, or indeed a big HPC facility. But nonetheless, they still need to be regulated. They're going to worry about how they can be sanctioned and who might be liable if they misbehave. We have even had a worry that anybody who uses our systems might become an employee, because the employment law sometimes, by using facilities owned by an employer, and they become worried whether they're kind of doing services for you and so on. So we had a little brush with that issue. Security. We did have a presentation with our security people, and they were just very keen that it was all firewalled off, and that they weren't able to get out to other parts of the university systems. I think they quite liked the short trust where you have to keep signing on again aspect that sort of goes with their kind of zero trust outlook. Okay, so things in our solution, which again, of course, is still a work in progress. We liked the projects aspect of the Isambard and Cambridge things. That really fits well. You might think there are other models for HPC systems, but the projects idea works well because our research group is doing a project and has a small number of people. This means you can get the project owner to vet the users, make sure that they fit in with perhaps the grants and other regulations, and then to actually authorize those users to put them on a list. So that when they are authenticated by MyAccessID, they then get in, right, and they can use the services. May mean you need to spend some time training the project owner in the security of the system, like don't hand out root to your users and things like that. we've already said it will need to be restricted and access to the rest of the university systems. You may need to get buy-in from people who provide other local storage services. I was thinking of storage there. But because it's already a university system, there are also lots of regulations all in force. So the regulations are begun to write for the system do a lot of importing by reference. They say these rules of the Information Services Department apply. You should read them and abide by them. Okay, so our story of signing up, it's taking a little while to get MyAccessID signed up. We were cooperating, we still are cooperating with JISC, who were looking to, I think, be an agent with for signing people up with the Central European system. They moved on for that. They're still working with the MyAccessID people to improve experiences and so on. But anyway, it was decided we apply directly in our own name, so we did that. And then nothing much happened at MyAccessID. And we got a friend with clout, so that was Chris Woods, who's already a user, to make representations at a user meeting, and suddenly we were signed up. Then we had to sign up again because we're experimental, so we had to fill in the same form but with a different URL. Anyway, when we did that, they were happy, and we've now been able to deploy a Keycloak instance that consumes those identities. So Sam Reese is going to give you a demo of what we've been able to do in a couple of weeks since we were signed up with the Keycloak and a basic web app. The MyAccessID people seem to be a little bit busy for this kind of signing people up for this kind of work. But we'll see how that develops, and I'm sure by the time we have a final report, I'll have a better answer for you on that when they're going to be going full steam ahead for smaller projects. Okay, so anyway, it's oh no, we've got one more. I've got a list of things here, right? This is the filling the form was really easy. Okay. You just had to fill in the form, note the secrets they give you, and wait for them to say okay. We did have to do a little bit of preparation. You did have to find out who you were. It's not uncommon for people to be confused about who the legal person is that they work for. So I had an interesting time looking up the history of the corporate body that is UCL. What else do you have to provide? You did have to write some regulations and publish those. They're up. They're a bit of a work in progress. It seemed very important that you had some fav icons for your website and a link to them. And I think that's because they go on a list of service providers that the Géant people compile. And then you had to decide on and name some people for of contacts for various purposes. And there's some values, some more technical values, which I suspect might come up in Sam's talk in a moment. So I'll hand over to Sam for a demo, and then we'll have another round of questions afterwards. Okay.
Thank you, James. Okay, so what I'll go through, just provide a bit of context, is what we've done so far. Proof of concept, as James says, we're currently still in acceptance. And I'll walk through how I've configured Keycloak, how we manage the configuration of Keycloak with infrastructure as code, and then a small example of a web application leveraging Keycloak's role-based access control through the client roles. Rightio. So I think, like everybody else, we've got multiple realms. master is just mainly for administrative purposes, whereas our main realm that will be utilizing the identity provider is separate, which is currently called UCL. Got a single identity provider configured at the moment, with a couple of mappers. As I say, we're still in a sort of exploratory phase of this. That's then routed out so it's accessible on the web. One of the things we use to manage all of this is Terraform. So we are using infrastructure as code to maintain this application. So any changes that we need to make. I mentioned that because if anybody else is doing it, one of the caveats I've found with this is that not everything is documented. And so sometimes you come across plural terms in the user interface, whereas the actual key value in the API is like a singular noun or verb. So one of the things we do is just sort of cross-reference the settings with the API and make sure that the config that is set. So in Terraform, we have to define an extra config parameter. And so we take these and pop them in. Currently, as I say, it's very minimal. We've got two mappers at the moment. So one is to collect the unique name from the attribute maps of MyAccessID itself. And then the other one we've got at the moment is to automatically assign a user that brokers through Keycloak into a group. And at the moment we've got one claim which is just for UCL, but it's a little bit of regular expression that picks up the domain of the user's email. This is helpful because when we assign clients to particular tasks or projects, then we can associate those groups with said clients, which then from a developer's point of view, they can begin to implement role-based access control on their routes. So here we've got a small Flask app with some roles assigned to it, admins and users, which then subsequently are attributed to some groups that you actually assign in here instead of there. So role that is then mapped to there. So to illustrate all of this, we've got a small Python application using Flask that will show the workflow of authorizing the user and authenticating it. So here we can log in. We've said we can use the OIDC option in Keycloak, pick our institution. That then redirects, and what we get here is then a successful login. If we want to inspect the token that comes back, we can do that. So if we want to look at the resources assigned to it and the roles, then we can. As you can see here, it's a member of the admin's roles for this Flask app client, which means if we go to that route, which is protected by a decorator, then we can just go to it and we should be able to get in. So that sort of demonstrates that part, and that generally concludes what we've been doing here. I think one of the interesting things is for us at least is the lack of documentation in the infrastructure as code side, but as I say, the workaround for that is to just interrogate the API, and that will bring back all the values you need, and then it's a like for like from that. As this grows, we intend to deploy this on a Kubernetes cluster and have high availability, so that the system itself running on our condenser HPC is a bit more resilient. There are a couple of things that I think in later sessions we'll be able to ask Christopher about, but the plugins that Bristol are using are very interesting to us. I think they would be useful from anything from accepting terms and conditions before logging in, to adding customized attributes to the users. I think that would be very useful. So that's everything we've done thus far. If anybody has any questions, then please feel free to ask. But thank you very much for your time.